This is a Sudoku solver using the ESP8266 microcontroller and the ILI9341 TFT touchscreen. So if I click on the bottom here to generate a random board, I'll get a board looking something like this. And if I click any of these numbers, the squares here are in black. But if I click any of these empty squares, then I'll get a blue square, meaning that I could enter a number from this keypad in here. So I could use the keypad to enter numbers and they were going to appear on the board. And if I want to delete them, then I would click here on 0 and it should be empty. So I could click check and it would show me that the answer is wrong. If I click solve, it would show me the answer for the board. And then I could click check again and it would show me that the answer is correct. So I could enter any board here, and as long as it doesn't break any of the Sudoku rules, I could get an answer from the solver. So although a board like this wouldn't generate a unique solution because there's multiple solutions, but if I click solve here, it could still generate a solution for me. I click X here to get rid of the board, and let's say I enter another board, but this time I'll break one of the Sudoku rules. So far this board doesn't break any of the rules, but let's say I enter a 2 over here. So now there's 2 of the same number inside of the same column. So now if I try to click solve, it would tell me that the board is invalid, therefore it can't be solved. So this is just another feature of the solver, or that it could only solve a board, obviously, if it's a valid board. And so this is like a player and a solver, because you could click here for a random board and then try to solve it on your own, and then click check to see if your answer is correct, or you could let it solve it for you, or you could enter in your own board and solve it. Basically, if you found a board online, or if you want to just check your own board. So this is my code for the Sudoku solver in Player. I'm not going to go through the entire code, but I'm going to summarize the main points of it. So these are the functions that I used. I put them here. And the solve function in particular and the fill-in function are both very important. So the solve function, along with the helper functions that are here before it, what it does pretty much is it backtracks through the board until it finds a solution that works. So these helper functions before it are pretty important, because what they do is it makes sure before inserting any of the numbers into the board, it makes sure that the number will not break any of the Sudoku rules. If it does, then it will go back again and try another number. So it brute forces the solution, but it has these mechanisms in place to prevent it from breaking Sudoku rules, which avoids a lot of unnecessary steps. And the fill-in function here, along with its helper functions, these functions over here, they will fill in the board before the backtracking occurs. So if you're doing this on a PC, you could probably get away with just using the solve function and its helper functions, and the Sudoku solver would probably be instant, even with the harder level boards that have fewer inputs. But if you're doing it on a microcontroller, it's probably going to be a lot harder because it doesn't have as much processing power. So using a function like this, which will deduce some of the board, like maybe with easier level boards, it would probably deduce the entire thing. It wouldn't even need to go through the backtracking. But with some of the harder boards, maybe you could get an extra like 20 inputs in, and then so you'd have like 20 to 30 numbers out of the 81 filled out, and so the recursion would require a lot less calls, and so it would be much quicker. So these are just optimizations that I did to make the code go a lot faster. So this is the solve function here, and it uses backtracking to find the solution. So this part is where the backtracking occurs, and so it's gonna keep calling itself until it returns true, and once it does, the board is solved. So it's gonna loop through all numbers 1 through 9 for a specific square, and it's gonna enter that number, and then it's gonna move on to the next square, and once it reaches a dead end, it's gonna backtrack and then enter in new numbers, and then it will keep doing this until it's solved. And if in the end it returns false. That means there was no solution to the board, and then we know it's an invalid board. Okay, so this is the fill-in function, which is gonna fill in some or all of the cells depending on the difficulty of the board, and it's going to do this before the backtracking takes place. So it does this to reduce the time that the backtracking takes and also the processing power. It uses two very simple sudoku techniques, the sole candidate and unique candidate technique. So the sole candidate techniques basically will check if the specific cell can only contain a single number. So if it rules out all of the other numbers, like 8 out of 9 numbers, then that last number could be the only one there. So it would fill that cell in with that number. And the unique candidate means that in a 3x3 box, if a number can't fit in any other cell, so let's say the number 4 can't fit in 8 of the 9 cells, then it has to belong to that 9th cell. So it's another form of process of elimination. So using those two techniques alone, you could pretty much solve a lot of easy boards and some of the medium level boards. And even for the harder level boards, it would fill in, let's say, maybe a couple cells, which would take time off of the backtracking. So these two simple techniques help optimize the Sudoku solver. So the display board function and the board touched function are two functions that are used for interacting with the board. So the display board is used to show all the graphics on the board, and the board touched function is used so that when you touch the board that you get the appropriate response.